What if the Titanic did not sink because of one fatal blow, but because of a chain reaction that began the moment ice opened its hull to the Atlantic? In the early hours of April 15, 1912, the largest passenger ship of its time vanished beneath the North Atlantic in just over 2.5 hours. For a vessel many believed was nearly unsinkable, the speed was shocking. But the reason Titanic sank so fast was not mystery. It was engineering, environment, and timing, all working against the ship at once. To understand the sinking, picture Titanic not as one giant hollow shell, but as a series of internal sections. Below deck, watertight bulkheads divided the ship into compartments. These vertical walls were meant to slow flooding by trapping water inside damaged areas. In theory, Titanic could stay afloat, with several forward compartments flooded. But the iceberg did not create one neat hole. It damaged multiple sections along the starboard side, allowing seawater into too many compartments at the same time. At about 11:40 p.m. on April 14th, Titanic struck the iceberg. The collision was not head-on. It was a glancing impact, and that detail matters. A direct strike might have crushed the bow, but it may have limited flooding to the very front. Instead, the iceberg scraped along the side, opening a long stretch of hull plating near the bow. Water entered several compartments almost immediately. The damage was not necessarily one dramatic gash. Modern analysis suggests it may have been a series of smaller fractures separated along the hull, but together they were enough. The sea did not need a huge doorway, it only needed paths in. Once the forward compartments began filling, Titanic's fate became harder to reverse. The bulkheads were called watertight, but they did not rise all the way to the top of the ship. They stopped at certain decks. As the bow settled lower, water filled the forward compartments, then spilled over the tops into the next ones, like water overflowing an ice cube tray. This progressive flooding let the disaster spread without any new holes. Titanic's size also worked against it. The ship was long, heavy, and built for comfort as well as speed. As the bow took on thousands of tons of water, the front pulled downward while the stern, still more buoyant, rose. That uneven lift and weight placed enormous stress along the hull and internal structure. The ship was no longer floating evenly. It was being bent. Construction details may have made the initial damage worse. Titanic's hull was made of steel plates held by millions of rivets. In some areas, especially toward the bow and stern, wrought iron rivets were used. Under extreme cold and collision forces, weaker or more brittle rivets could fail, letting seams open more easily. That does not mean Titanic was cheaply built. It was a major engineering achievement. But the collision exposed vulnerabilities in materials and design that were not fully understood in 1912. The environment mattered too. The North Atlantic was brutally cold, and the iceberg field left little time to react. Once the lookout spotted ice ahead, the crew had only moments. The ship turned, but not enough. The glancing strike created exactly the kind of widespread side damage the compartment system was least able to survive. Then came the mathematics of water. Seawater is heavy. Every minute, more weight pulled the bow lower. As the bow sank, more openings slipped below the waterline, increasing the flooding rate. Pumps could slow water in limited areas, but they could not remove it fast enough across multiple compartments. Titanic was losing a race against gravity. That is why the sinking accelerated. At first, the decline may have seemed slow and controlled. But as water moved from compartment to compartment, the angle increased. The forward decks dipped closer to the sea. The stern rose higher, and structural stress intensified until the ship eventually broke apart before the final plunge. Titanic sank fast because no single defense was enough. The iceberg damaged too many compartments. The bulkheads delayed flooding, but could not stop it. The riveted hull and plate seams were vulnerable under impact. The pumps were overwhelmed. And the ship's own weight distribution turned flooding into a cascading failure. The tragedy of Titanic was not simply that people built a ship they thought could never fail. It was that they built a ship for risks they believed they understood. The iceberg revealed the limits of that confidence in the coldest, harshest way.